Hello, ladies and gents. Mr. D'Souza here with a geometry lesson. We're going to talk about when triangles are congruent. So, first things first, when we say triangles are congruent, that means all the sides are congruent and all corresponding angles are congruent as well. This is a typical picture of showing two triangles being congruent. We remember with the same number of tick marks means that those corresponding sides are going to be congruent. So if you look at this side, so side AB, it has one tick mark. Side DE also has one tick mark. That's notation to say, hey, these two have to be the same. Similarly, you can say the same thing with angles and their arcs. If we look at, let's say, angle C, it has three arcs. Angle F has three arcs. Since they have the same number of arcs, we can say that they're congruent. And you've also seen congruent statements like this, saying, hey, this triangle is congruent to this triangle. But there's a little bit more to this congruent statement. Let's check out the first two letters, A and D. What do you notice about angle A and angle D? Well, they're congruent. Let's look at angle B and angle E. B and E, boom, boom, they're also congruent. And angle C and angle F, boom, they're also the same. So the letters are in the order in which the angles are congruent, but it gets even better because it's also in the order of the sides. So let's say if I pick the first two letters here and the first two letters here, side AB and side DE, well, we already talked about them being the same. If we pick, let's pick the outer two letters. So AC is this one, and DF, which is also this one. They're also the same length too. So when we write congruent statements, we write the letters in such a way that it tells you which angles and sides are congruent. So let's talk about, well, how can we identify when triangles are congruent? So there's 5 ways. The first way is side, side, side. So that means if all 3 sides of one triangle correspond to another 3 sides of another triangle and are congruent, then both triangles are congruent. In this one, side angle side postulate, if you have 2 sides of one triangle congruent to 2 sides of another, and an angle in between those sides are also congruent, then both triangles are congruent. We call that the side angle side postulate. Angle side, if you have 2 angles congruent to another 2 angles in another triangle, and a side not in between those angles are congruent, then both triangles are congruent. Angle side angle is similar to side angle side, but the reverse. So if you have 2 angles in one triangle, congruent to 2 angles in another triangle, and a side in between are congruent, then the 2 triangles are congruent. And last but not least, the sneaky one, we don't see this one enough, but it's good to mention, the hypotenuse leg theorem. All this says is, hey, if you have 2 triangles that are right triangles, and you have one hypotenuse congruent to another hypotenuse, and you have a leg congruent to another leg, then the 2 triangles are congruent. And let me just mention, some people forget where the hypotenuse is. The definition for the hypotenuse is the longest side in a right triangle. But the easiest way to remember where it is if you outline your right angle points to your hypotenuse, always. Alright, so let's do some examples. So with these examples, we're going to talk about, well, are they congruent? If so, what's the postulate and what's the congruent statement? So this one I tried to make fairly simple. This one only includes sides, and out of the 5 postulates, that's only side, side, side. Bam, side, 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 side. So yes, these are congruent, and that's the side, side, side postulate. Or I personally like to write side, side, side is congruent to side, 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 mainly because it kind of mimics this idea of writing a congruent statement. I'm essentially saying 3 sides of one triangle are congruent to 3 sides of another triangle. So there's a couple ways to do this. If you notice, if I were to rotate this triangle so that this is pointing down this way, you'll see that both these triangles overlap, and you'll notice that S goes with V, T goes with X, and U goes with W. But let's say if you can't visually look at that, check this out. S is right here. it's in between two sides that has 2 tick marks and 3 tick marks. If I want to find the same angle in the other triangle, I'm going to look for the angle in between 2 tick marks and 3 tick marks. So in between 2 tick marks and 3 tick marks is this angle, angle V. You can do the same thing. Let's do T. T is in between 1 tick mark and 2 tick marks. So what's in between 1 tick mark and 2 tick marks? X. So X, and then the last one has to be W. So this would be the congruent statement. Let's do another example. So, are the triangles congruent? If so, write the postulate and congruent statement. So, check out this. I see a side, I see an angle in both, but that's it. But you have to remember, when you're looking at pictures, especially in geometry, you should always look out for vertical angles, linear pairs, and reflexive property. And in fact, I see the reflexive property here. The reflexive property is when, well, there's a couple ways that we can mention it, but in the context of what we're doing right now, when two sides, or rather one side is being shared between two triangles, we can say that this side is congruent to itself. So, I see a side, an angle, and a side in this triangle, a side, angle, and a side in this triangle. Yes, these are congruent because of the side, angle, side postulate. Or another way, my favorite way, is side, angle, side is congruent to side, angle, side. And we can do the congruent statement. So A, B, D. So A to B to D. So I need to go from one point that goes through 1 tick mark to here. That must be C. B is the same as B. And then they both go back down to D. Alright, let's do another example. So this one kind of looks like the first example that we did. But let's dig a little deeper. We could say a couple of things. We could say, definitely, we have a side thing going on. However, there's a lot more in this picture. So we always tell you that when in doubt, try to fill in as much information as you can in the picture. So, do you see any vertical angles, linear pairs, or reflexive property? There's definitely not reflexive property. And yeah, while there are linear pairs, I'm not too sure if that's going to help us, but I do see some vertical angles. Right here, and right here. So, in addition to saying side, now we have side, angle, side. But let's dig a little bit deeper. Check out how they write the tick marks. Let me make this a little bit more obvious. If I draw a picture like this, a triangle, and I put 2 tick marks like that, what kind of triangle does it force it to be? Isosceles, right? And in an isosceles triangle, the angles opposite those congruent sides are also congruent. So if you check out this, if you tilt your head to the side, this is an isosceles triangle. So this must be congruent to this, right? Similarly, over here, this is also an isosceles triangle. So that means this is also congruent to this. Boom. And if you notice, we're digging really deep here, ladies and gents, right? These are not necessarily parallel lines, but if you notice, if I fill it in, do you see what I see? These two angles are congruent. Those are alternate interior angles. So that means that these two lines must be congruent by the parallel lines theorem. So if that's true, then these angles also must be the same. What I'm trying to say here is that you could use any of these postulates, except for HL theorem, because these are not right triangles, to prove that these two triangles are congruent. So it's definitely yes. If we're going to write the congruent statement, HJK, that would be, so H to J goes from 1 arc to 2 arcs, so that's ML. So it's going to be MLK. And you can use side, you can use side, angle, side, you can use angle, angle, side, and you can also use angle, side, angle. All right, let's move on. So these are a little bit, well, just a little bit different. Um, I have no information filled in. I give you some information, and we're going to fill in the information and see if they're congruent. This is kind of leading us to this idea of how to prove triangles are congruent, which we'll do in another video. But all you need to be able to do first is to look at a picture, use information that's given to you, and fill that information in and see if they're congruent. So this says CD is congruent to AB. Boom. Boom. It also says angle B is congruent to angle D. So angle B is congruent to angle D. Again, I'm not going to go through the whole digging deep in here, digging deep here kind of thing, but if you turn your head sideways, these are alternate interior angles. You can draw parallel lines. That means these angles are also congruent, but I'm not going to get there because it's a little too much right now. Let's just focus on what they give us, right? So you're going to notice that there's not enough information here. So without doing that parallel lines cut by a transversal stuff, what you could also do is notice, hey, I see vertical angles here. And you can easily say, this is angle, side. And what you can do is you can say, well, triangle C, D, E. So C to D to E. So C, D. So that has to be A, B, E. So that must be congruent to A, B, E. Okay? Now, again, we could have done the parallel line cut by a transversal stuff, because we do see that if we draw in our parallel lines cut by a transversal, these two angles are congruent, so that means that they're alternate interior angles. Therefore, what we could do is we could say, well, these are also congruent, and then you have a boatload of stuff you can say. You could say angle, side, angle. We already have angle, angle, side. The list goes on. Let's do one more. So this one looks a little bit more complicated. Let's just check it out. So, again, they give us some information. Let's see what we can do. Given Jn is congruent to Lm. So Jn is right here. Lm is here. Nk is congruent to Mk. Boom. So Nk, Mk. And angle N is congruent to angle M. Oops, let me make that a little bit more of an arc. Boom. Simple. 1, 2, 3. This is going to be side, angle, side. Postulate. Let me just double check. This would have been wrong. Right? Postulate. Okay? So, write a congruent statement. Again, because I'm creating the congruent statement from the beginning, like no one gave me any information, I get to choose the letters that I want to start with. So, I'm going to do JNK. JNK. Now remember, I started with the angle that's not in the middle. It doesn't have any markings, so that must be L. So triangle L. Bop, bop. So it goes bop, bop. So LMK. Okay. I hope this video is helpful. The main thing that you got to know, congruent statements are in a specific order because they tell you what angles are congruent and what sides are congruent. And then there are 5 postulates that you can use to figure out, or rather to determine, if two triangles are congruent. And last but not least, you're going to get pictures. You need to mark up your diagrams. Based on your marked up diagrams, you should be able to determine which one of the postulates allow the triangles to be congruent. And last but not least, there are 3 things you can always see in a picture: vertical angles, linear pairs, and reflexive property. Have a great rest of your day, and I'll see y'all later. Bye-bye.